Okay, welcome to Credit 3 Statistics. We have a little hint video here for day 1. Okay, let's get started. So on day 1 you're going to do your introductory video and make your predictions on the Google form and see the results video. Then you're going to watch this vocabulary video and take your notes in your math notebook about that. And then watch this video on histograms. So histograms look kind of like this, where you have a whole bunch of just points that you can say, like, oh, there's male bears that are, 60 inches long, and there's so many of them here, so many that are 65, so many are 70, and so on. So that's what a histogram looks like. Okay, so you're going to compare the two distributions that are on the previous page between male bears and female bears, and how are the two distributions fundamentally alike or fundamentally different. And basically the idea is, like, how are they spread out. So something that's kind of like that versus something that's kind of like this, right? We have a lot more centered around this area versus this one's more spread out. So that's the kind of idea that we're looking for. How are they fundamentally different? And maybe these have the same kind of mean average between the two. Compare the centers of the distributions, compare the spreads, that sort of stuff. Describing the shape. So this is what we call a normal distribution. That there's kind of in the middle we have the mean, the most amount of results occur in the middle. But if it's skewed to the right, so you see this little tail going out to the right side, then we have the most actually on the left side, right? So the tail, it tells you if it's skewed to the right or if it's skewed to the left. Okay. Describing the center, the spread. So the range, I know that the range is kind of the range of values from the small to the high. So you have this whole range of values, but you can also talk about the range in terms of what's the difference between the maximum value and the minimum value. So if it's like 150 is the high and 50 is the low, so it has a range of 100 is the difference between the two. Okay, talk about dot plots. So just take a look at this histogram dot plot and answer those questions. So talking about so the average ticket price, there's like really high ticket prices and $40 ticket prices. So they fall in these different categories, right? There's the frequency of the number of $40 tickets is 4. There's 4 tickets sold that were $40 on this survey, I guess. And then we go over to here. So this might be a little bit confusing at first, but we're going to switch. Instead of the frequency in number, we go to the relative frequency as a decimal. Out of 1.0 would be 100%. So 20% fall in this $40 price category. So you have to kind of look back at this previous chart to fill in this table here. So there was 4 tickets that were in the $40 to $50 range. And then in the $50 to $60 range, it's not going to be just the number of $50 tickets, but it's the 50 and 60. Or actually, no, it's just the 50. So you go above that range. So 50 to 60. So what is in that range of 50 to 60? So there should be 3 there. So I'll go ahead and fill that one in. So there's 3 in the 50 to 60 range. And the relative frequency would be, I guess, 3 out of 20 if there's a total of 20 tickets. So you can figure that out. I think it's 0.15. And for each one, you'll fill that out. And then you'll graph your own. So I'll graph the 50 to 60 range was 0.15. So it would look just like that. So you can do the rest of them. So then up next is this box and whisker plot video. So it describes, so you want to watch that whole video, but it describes how to make a box and whisker plot with a maximum, a minimum, a first quartile, median, third quartile. And The mean is not described on the box and whisker plot, but it's given to you there. So you have this minimum. So both in this graph here, you're gonna draw both of them side by side. So you're gonna have like a box plot here, and I'll just do the minimum is at 0, and then you have kind of your median, and then you're gonna build the box. So wherever the medians are, that's where that line goes, and then the first quartile, so Q1, and the third quartile, Q3, this is their median. This is your minimum, and then your maximum, whatever it is out here. So I think this is wrong. I'm just throwing it out there. But then you're going to do the second one. I don't know what it looks like, if it has a different range. Something like, I don't know, like that. So you're going to put both on top of each other and according to these values right there. Okay, and then finally you're going to do this investigation about texting. So this girl Rachel, she wants to do a little scientific discussion with her mother about how much texting she should be doing each day. And she surveys her friends, 24 of her friends. She asks the following question: what is the average number of texts that you send each day? And here's the data that she gets, right? So you're gonna plot this data. So how many texts are in the 20 to 40 range? So you're gonna count them up, and how many are in the 40 to 60 range, and so on. And then you graph them on this histogram. And then you're going to make a box plot representing that data here. So from the minimum, the first quartile, and so on. And over here, Rachel, so she compares the data with her mom. Rachel had created a box plot using her own data she collected, and it looked quite different than when they combine their data. So you're going to compare her mother's box plot with Rachel's. One thing on here that I wouldn't be too worried about it, but these values right here kind of represent outliers. So they don't actually go into the minimum, and the reason for that is that the minimum can only be 1.5 times the interquartile range. This is the interquartile range. So if it's more than 1.5 times the interquartile range outside of Q1 or Q3, then they don't really consider it to be a valid point. So these are not included in the graph. But I wouldn't worry too much about that. It's kind of more of an advanced thing. But just pretend like this is the minimum and the maximum. Then I want you to come up with your interpretation of what this information tells you. What does the median tell you? What does the interquartile range tell you? And also, what is a reasonable number of texts that Rachel should send per day? So, given this data, we could look at things outside of this data, but we want to just kind of focus on this data. What would be a reasonable number of texts for Rachel? Like, we're not going to look at like, is her family in the middle of bankruptcy, like that? Then she should probably not have a texting program. But we just have to assume that those other things aren't a factor. Okay, and yep, just go ahead and answer that question and justify your response on that, and then we'll see you in day 2.